Hello friends, so in this video we will be looking at a question that came in sequential sampling plan. So based on this question we are going to study the theory part of sequential sampling plan and how to do this question, right? So we will first understand what sequential sampling plan using this graph, right? So this is the plot for sequential sampling plan. So sequential sampling plan is nothing but an extension of the double sampling plan and multiple sampling plan. Now this is the scenario that we are going to do here. Let me just explain using this graph. Now let's say this is the number of samples in and this is the number of defectives, right? So now we take a sample and if the number of defectives, now we will find two lines, right? So this is the rejection line and this is the acceptance line. Now based on the sample size, so we have to first find out the equations for these two lines, right? So these are the equations that we are going to use. So for finding out the equations for these two lines, so we have to use some equations. So first let me tell them for you. So first we have to find k is equal to log p2 into 1 minus p1 divided by p1 into 1 minus p2. So this is the first parameter that we have to find here. After that we have to find out what h1 is, right? Because in the equation we have h1, in the acceptance line we have h1, right? So first we have to find out this h1. For finding out h1 and h2 we have to first find out the parameter k, right? So that is nothing but log p2 1 minus p1 divided by p1 1 minus p2. Now h1 is equal to log 1 minus alpha divided by beta divided by k. So this is the equation for h1, log 1 minus alpha divided by beta. So log value of this ratio divided by k, right? So we should have already found this k value. After that h2 is equal to, h2 is in the equation of rejection line. So h2 is equal to log 1 minus beta, right? So log 1 minus beta divided by alpha divided by k, right? After that we have to find another quantity called s. S is nothing but log 1 minus p log 1 minus p1 divided by 1 minus p2 divided by k, right? So divided by k, right? So these values we have to find because this s is also in the equations of acceptance and rejection lines, right? So now first let's read this question and then we will understand what this graph is all about. So determine the sequential sampling plan with an OC curve that goes through the, so this is an operational characteristic curve, goes through the points, not this is, okay, so there's an OC curve going through the points this, right? So the coordinates of the OC curve are also given. Now P1, so from the coordinate points we can extract the information P1, right? So let me change the color. Now we can say P1 is equal to 0.02, alpha is equal to 0.05, P2 is equal to 0.1 and beta is equal to 0.1, right? So first you should first you should extract these four parameters or quantities from the equation, then we can substitute the values in the equations that we have studied. Anyhow we have to remember these equations because in the examination we cannot expect the examiner to give these all equations right? Okay, I'm sorry. So here first we will find out the value k, because for the equation of h1 h2 and yes, we will require k. So k is equal to log p2 into 1 minus p1 divided by p1 into 1 minus p2 divided that's all, right? So now we will just substitute log P2 0.1 into 1 minus 0.02 divided by 0.02 1 minus 0.1. So you have to be very careful while substituting the values and all, because ultimately the error will bring you to the incorrect answer. So log, you you also may try along with me. Log 0.1 into 1 minus 0.02 divided by 0.02 into 1 minus 0.1 equal, so it gives me the answer. So I have just entered the values in the calculator and got this answer. If this is incorrect, you may let me know in the comment section, but I will follow the same procedure. Sometimes the answer might be wrong if I make mistakes here, right? So 0.73595. Okay, that is enough, or otherwise we can say 0.736 also, right? Okay, let me write that way. Right, now we can find out H1 and H2. Okay, so let me find out H1 and H2 here. So H1 is equal to log 1 minus alpha divided by beta divided by k, right? So since the value that you find here will affect this H1 also, because if this is wrong, then this also will be wrong, so you have to be very careful. So H1 is equal to log 1 minus alpha divided by beta divided by k, right? So now we know all the values in the equation. So log 1 minus alpha is equal to 0.05 divided by 0.1 divided by k, 0.736, right? So we will find out the value for this. Log 1 minus 0.05 divided by 0.1 is equal to 0.9777236,053. You also should have got this answer, and then divided by 0.736 equal to 1.3284, right? Okay, so we have found out the value for H1. Now H2 is equal to log 1 minus beta divided by alpha divided by k, that will be equal to log, now we know the values, 1 minus 0.1 divided by 0.05 divided by 0.736, so that will be equal to again I have to enter the values in the calculator. You also may enter and find out the values along with me, then we will compare, right? So if you got a different answer, you can let me know in the comment section. Log 1 minus 0.1 divided by 0.05 is equal to 1.255272505. Then I have to divide this value by 0.736. So I got 1.7055. Okay, now again we have to find out S also, because we have to write down the equation for the acceptance and rejection lines. So let me now find out the value for X. So I will use the space here. Right, so let me use a different color. What color will you use? I prefer this black color now. Okay, S is equal to log 1 minus P1 divided by 1 minus P2 divided by again K. So we know all the values. Log P1 is equal to 0.02, right? Yeah. 1 minus 0.02 divided by 1 minus 0.1 divided by 0.736. So that will be equal to, now let's find out the values together. Log 1 minus 0.02 divided by 1 minus 0.1. So I got the answer 0.0369835666625. Then I have to divide it by 0.736. Okay, right. So that is equal to 0.05024, but I will omit the remaining decimal places, so 0.05. Now we will come to the graph, right? Okay. Now if the what it says is now, okay, now let's consider we take 10 items from the lot, so that is the sample size. Now if the number of defectives is equal to 1, then we will continue the sampling until we get the number of defectives within the acceptance region, right? So this is the acceptance region. Now again we take 20 samples, right? So in the second sampling plan we get 20 samples or 20 items in the next sample. So let's say we get 2 defectives item. But anyhow, in this region, now for example, if we take 10 items from the lot, that is n, capital N, we take n, right? So from the lot we take sample size. So if we take 10 samples, I mean like 10 items, and let's say we found 4 defectives, then we will definitely reject that lot otherwise. Now we take 10 items and we found 1, then we will go for the second sampling, right? So in the second sampling we take 20 items and we found 2 number of defectives, so again we have to continue the sampling process. Now if you take 30, then again in the 30 also we have 2 items, so we will take the next sampling. So if we take 40, then now before that we will sketch these lines based on the equation we have derived, right? After that, if we take 40 items and if we found only 2 defectives, then we will accept the lot, right? So this is the story behind the sequential sampling plan. Now we have found out all the things. Okay, so we will just, okay, so estimate the acceptance and rejection lines. So now for acceptance lines, XA is equal to minus H1 plus SN, right? Then XR means rejection line equation is equal to H2 plus SN, right? So S is here nothing but the gradient of the equation. XR means that is the Y value, right? So Y is equal to mx plus C. Now you can see this is the intercept. H2 is, okay, now we will just analyze this equation. So here this is XA means that is Y, right? So Y is equal to M. So this S is gradient, N is the N is equal to x-axis, right? So N is x-axis, then S is the gradient, right? So you see minus H is the intercept. So right, now we will see XA is equal to minus H. We have already found minus H, right? H is equal to 1.384. H is equal to 1.3284. So minus 1.384. Oh. 1.38. Okay, so let me explain it. XA is equal to minus 1.3284. Okay, 3284. So XA is equal to minus 1.3284 plus S we have already found 0.05 n, right? So n is here x and this is y. So this is in the format of y is equal to mx plus c. Again, XR is equal to H2 we have already calculated 1.7055 plus 0.05 into n. Then again they are asking, so these are the answers, right? So we have done the first portion of the question. Now we will come to the second portion. Right, at least how many units sample size have to be inspected to accept the lot? So if we want to accept the lot, it should fall in this region, right? So now we have to find out the minimum size of the sample, minimum sample size to be inspected in order to accept the lot. For that we will just put XA is equal to 0 in this equation, right? So based on this equation, so XA is equal to 0 in order to get the minimum sample size for inspection in order to accept the lot. So now XA is equal to 0 minus 1.3284 plus 0.05 n is equal to 0. So n is equal to 1.3284 divided by 0.05. So let me find out the value for that. 1.3284 divided by 0.05, it gives me 26.568. 26.568. So I have to take minimum of 27 samples in order to inspect whether to accept the lot or not. So approximately equal to 27 samples, right? So hope you enjoyed this video and got some knowledge from it. So we will meet in another video. Thank you. Bye.